Welcome to day 2 of Fibroid Summit 2023, Focus on Research. Our annual Fibroid Summit program was developed to share emerging fibroid and menstrual research with our community. The summit is unique because it is hosted by patients and because most of the questions come from patients who have the unique lived experience of managing fibroids and in many instances have undergone treatments. When women are diagnosed with fibroids, they have simple questions. What are fibroids? What caused the fibroids? What are the treatment options? Will they come back? And how do I prevent them from returning? To a degree, some of these questions can be answered, but sadly, there's still so much that can't be answered. Fibroids are prevalent, answers are needed, and research is critical. On this last day of the summit, we will continue the focus on new research. Please click on the chat pop-up and ask questions during the presentation. After each presentation, ask the researcher your question so you have an opportunity to have your question addressed in real time. Next, I'd like to introduce Dr. Shannon Whirledge. Dr. Whirledge is with the Yale School of Medicine, Laboratory for Surgery, Obstetrics, and Gynecology. She's an associate professor in obstetrics, gynecology, and reproductive sciences. After the presentation, Dr. Whirledge will join me for a live question and answer segment. Welcome, Dr. Whirledge.
Wonderful. Thank you very much for the invitation to join the Fibroid Foundation today for the annual Fibroid Summit. I really appreciate the opportunity to come and share a little bit about my work and as well as my understanding as to how stress and other hormones may play a role in uterine fibroid, the development and the disease itself. So the learning objectives for today, what I really want to do is first start with an introduction to the endocrine system, as well as that's really our hormone producing system, so that everybody can start with the same understanding of where our hormones come from and what they may do. I'd then like to go a very brief overview of how the hormones, specifically the ovarian-derived hormones, estrogen and progesterone, are known to regulate uterine fibroids and why that has led to them being targeted as one of the first lines of defense in therapeutics against uterine fibroids. Then I'd like to share a little bit of our studies that we've shown what stress hormones may do in uterine fibroids. And then I do have a little bit of information as to why stress hormones may play a role in the development or the pathology of the racial disparities in uterine fibroids. Finally, I'd like to end kind of on a positive note and explain how targeting stress hormones may lead to novel therapeutics in the fight against this disease. So as we start first by talking about what the endocrine system is and our hormones. So really the endocrine system is our hormone producing system. And this may seem like a concept that's not necessarily familiar, but the endocrine organs are actually organs that you are very familiar with. So for instance, your ovaries, your brain is an endocrine organ, your heart is an endocrine organ. There's a lot of endocrine organs throughout our body that regulate key processes such as our blood glucose level after we've had a meal and when we get hungry. And there's key features of the endocrine system. So one of the primary features of the endocrine system is that it produces hormones that are then secreted directly into the circulatory system, travel through our blood, and target cells that may be really far away. One good example of this is that our brain makes a hormone that will then travel all the way through our bloodstream and act on the ovary to regulate fertility as well as the production of other hormones. So that's kind of an example on how it's secreted into the circulatory system and acts on a distant target, so something further away in the body. One of the other key features of the endocrine system, and something that's really important to remember for kind of this full 30 minutes that we're going to be spending together, is that these hormones then are able to target those distant organs and distant cells by binding to a receptor that is really specific for that hormone. So the estrogen can act because it can bind to the estrogen receptor and elicit some sort of response in that cell type. So it makes that response really specific for each hormone type. And then in response to that binding of the hormone to its receptor, almost like a lock and key mechanism, it alters the activity of that cell. These hormones really work by having a feedback loop. So their regulation is always typically under control in normal physiology. So there's a feedback loop in which, for example, after we eat a meal, our blood glucose levels will change in response to the elevated glucose levels. And then when we're hungry, our body will then respond by producing hormones that will remove glucose stores and add them back to our bloodstream. So that's an example of how our hormone system really functions to kind of maintain homeostasis, always trying to maintain an even kind of keel within our body. And so again, kind of some examples of, while the endocrine system may be a foreign topic or a foreign terminology, that they're really things that we're really familiar with. So again, I mentioned our brains, our adrenal glands, which are the endocrine producing organs that produce the flight or fight response, as well as our stress hormones, and our ovaries as well. And so as far as what's known about hormone regulation of uterine fibroids, probably the main players in what we understand as far as how our uterine fibroids developed, how do they grow, how do they get so bulky, is the female sex steroids that are derived from the ovaries. So estrogen and progesterone, which again, as I mentioned earlier, these hormones act as a lock and key mechanism. So here's a kind of diagramming of how these things function. So this, peach circle is our hormone. It's going to bind to its hormone receptor. And I'm just kind of generally termed as HR here. Once it's bound to its receptor, it's going to go then into the center of our cell. And what it really functions as is almost like a puppet master. So it goes and binds our DNA and regulates the expression of hundreds to thousands of genes. And these genes in fibroids have been demonstrated to be key for producing extracellular matrix, which is the thing that makes our fibroids so stiff, the growth of cells within fibroids, their proliferation, so how many of the cells we have, as well as their cell death, so whether or not they survive for a really long time or they are susceptible to dying. And we can see in this lower image that both the estrogen receptor and the progesterone receptor are highly expressed in uterine fibroid tissue. So expression here is marked by the brown staining, whereas all the cells that are just blue are cells that don't express either the estrogen receptor or the progesterone receptor. So again, you can see throughout this uterine fibroid tissue section that both of these receptors, these hormone receptors, are highly expressed throughout the fibroid tissue. So it's not surprising that this tissue is very responsive to our female sex hormones. And we know that these sex hormones can increase the production of extracellular matrix, increase growth and proliferation of the fibroid cells, as well as decrease the amount of cell death. So that means there's going to be more fibroids or more cells within that fibroid itself. And so for those reasons, this is exactly why the estrogen receptor and the progesterone receptor, so those sex steroid receptors and the sex steroids themselves, estrogen and progesterone, have been targeted as one of the mainstays of therapeutics against uterine fibroids. So by kind of shutting down this hormone release stemming from the brain and acting on the ovary to produce estrogen and progesterone, we've been able to block the action of estrogen and progesterone, thereby having many beneficial effects for uterine fibroids. However, what we can see in this image on the right side of the screen is in the pink are various tissues that express either the estrogen receptor or the progesterone receptor throughout the body. And this is one of the reasons why we can't have long-term therapeutics that target those receptors. Because of the expression of the sex steroid receptors, estrogen receptor, and the progesterone receptor in regions such as the brain, the muscle, and the bone, those negative effects, so almost the effects that are off target of the ones that we want to happen in the fibroids, prevent patients from being able to stay on these hormone modulating factors for too long. Now, due to my lab's interest in the stress hormone signaling pathway and some early evidence demonstrating that stress hormones may also influence uterine fibroids, we really wanted to dive a little bit deeper into what those potential effects may be. So our stress hormones, while we think of these very negatively, they're actually serve one of those beneficial roles. So as I mentioned earlier with the endocrine system, the hormones in our body really like to keep things tightly regulated in as an even keel, right? So keep everything, when something rises, there's another hormone that will then bring it back to normal. So always kind of keep things in normal. So in fact, our stress hormones are actually released every night right before we wake up to mobilize our glucose stores, which is one of the reasons that when we wake up, we're not immediately starving, because our body has already prepared us for waking up by releasing our stress hormones, the glucocorticoids, in response to circadian rhythm. So our time we go to bed at night and the time we wake up in the morning. But in addition to that natural rhythm of stress hormone release or glucocorticoid release, these hormones can also be released in a response to various stressors. So this is where the terminology of stress hormone comes from. So in response to an environmental stress, dietary stress, so such as famine, which is really a historical model of stress release, perceived stress, which is highly demonstrated or well demonstrated in uterine fibroid patients, psychological or physical stress, our body activates the brain HPA axis, so the hypothalamic pituitary adrenal axis, to produce the response or the release of glucocorticoids. Now, as I mentioned, historically, what we've used to study and really understand the stress response has been some models that aren't necessarily as relevant as they were at that time. So things such as famine and war have always been really great models for stress release. But what we should also appreciate is that there's probably more common occurrences that we may not realize are highly linked to our stress hormones and how they're released in our body. So one example of this is food insecurity. So the USDA estimates that 1 in 6 households with families experience food insecurity. And in general, about 1 in 10 households currently experience food insecurity. And it's been demonstrated that food insecurity is tightly related to levels of stress hormone release. Another example that is highly relevant and certainly really understood now to be quite frequent is various racial discrimination and other microaggressions. So in this example on the bottom right panel, this is diagramming the levels of cortisol. So that's our stress hormone, the glucocorticoid that's released. And that what this study demonstrates is that in response to racial discrimination, not only is there an acute, immediate response of stress hormones or cortisol into our bloodstream, but this response also is maintained over time. So they saw this acutely, so right at the time that it occurred, but also at the next day. So there seems to be this kind of long-term effect of various stressors, modern-day stressors that we experience now. And this kind of contributes to this new theory of stress signaling in our body, termed allostasis or allostatic load, which is a term that we've borrowed from the engineering field. And this is used to kind of describe any threats to our, or perceived threats to maintaining that homeostasis, so that even keel that the hormones are trying to maintain. And so in this, the left-hand panel of this really describes how hormones try to always maintain that even keel. So in response to a stressor, our body will release other hormones to maintain us back to, go back to normal. So the stress hormone cortisol or glucocorticoid plays a function in returning the body back to this set point. The problem becomes is that when we have continuous stressors such as racial discrimination or food insecurity, we now then change this wave or this set point of where our stress peaks to and where it comes back to. So we've now set a new set point for allostatic load. So the stressor again induces stress mediators or stress hormones. Our body responds and tries to bring things back to normal. But when you have continuous stress, you can see that this pattern increases so that you have a new point where your body kind of maintains itself at a high stress state. And so while this response to stress can be beneficial, so you can imagine a scenario in which there's an acute stressor and our body has to release glucose to respond to that stressor. When that stress becomes chronic, the response to glucose and our body's need for glucose changes, and that contributes to diabetes. So you can imagine other disease processes are also impacted by the fact that our stress hormones now in individuals that are chronically stressed or may experience stress on a regular basis have now been kind of modulated so that we're at a different set point. So as I mentioned, so let's now bring us back to uterine fibroids. As I mentioned, in response to either the daily release of glucocorticoids or acute stressors or chronic stressors, our body activates its hypothalamic pituitary adrenal axis, thereby causing the adrenal glands produce hormones, so endocrine hormones that enter our bloodstream and travel to distant organs in the body, including the uterus. So the uterus itself is a rich source of glucocorticoid receptors expressed in all cell types in the uterus. So within the uterus, we have the ability to bind to its receptor and do the same things that the estrogen receptor and the progesterone receptor do. So they act as, again, as puppet masters, kind of regulating the expressions of thousands of genes. But what's also really interesting is that we can also locally modulate the levels of this hormone. So we can inactivate it in tissues where we don't want the stress response hormones to be too active. And so what we know about uterine fibroids and uterine tissue is that, yes, the uterus, and specifically the myometrium for which uterine fibroids arise from, expresses the glucocorticoid receptor, so that stress hormone receptor. So here you can see in the brown staining are all the cells in a normal myometrium that express the glucocorticoid receptor. But what I hope you can appreciate is that in the uterine fibroid tissue that we have more brown staining, so a higher level of expression of the glucocorticoid receptor. So that means that this uterine fibroid tissue already has a difference from the normal myometrium from which it arises, and it's potentially more susceptible to stress signaling. Now, in response to exposure to stress hormones, we can see that the uterine fibroid cells will increase in their cell proliferation, they'll divide more. And another new thing that we've discovered is that in addition to inducing growth and proliferation of uterine fibroid cells alone, it can actually work in concert with the sex steroids, estrogen and progesterone, to elicit an even greater effect. So in this experiment, what we did was we treated the uterine fibroid cells with either estrogen, which is the solid brown line, or estrogen plus the stress hormone cortisol. And what we see is that estrogen alone induces the growth of uterine fibroid cells compared to a no treatment control. But the addition of the stress hormone plus estrogen creates an even greater increase in the number of cells. Now, progesterone appears to be a stronger inducer of proliferation in uterine fibroid cells. So we can see in the solid blue line that the addition of progesterone to the uterine fibroid cells in culture induces a steep increase in proliferation of these cells. But that number becomes even greater when we add stress to those ovarian hormones. So the addition of stress on top of a system that's already primed to induce proliferation, such as progesterone and estrogen, creates an even worse environment for uterine fibroid growth, or better for the fibroid cells, but worse for the patients, obviously. And what's really interesting is that this effect is not true in the normal myometrial cells. And the normal muscle cells of the uterus, the effect of estrogen and progesterone are blunted. So estrogen and progesterone can uniquely induce proliferation in these fibroid cells. So something is different about these fibroid cells. And that the addition of stress hormones to either estrogen and progesterone no longer has that kind of exponential or additive effect. So it's almost as if in the fibroid cells themselves, there's almost like a Batman and Robin phenomenon in which the stress hormone is working with the normal hormone receptors to create potentially even greater proliferation regulated genes, so driving that process. So in addition to cellular number, fibroids are also highly characterized by the production of extracellular matrix. That really is what gives them that kind of stiff feeling of the uterine fibroids themselves. Almost to me, it's like a golf ball or a tennis ball, something that's really hard. And here you can see in this image of a cross-section of a uterine fibroid tissue that the staining in red demonstrates where that extracellular matrix is, so the stiffness component of the fibroid. So all the blue is marking the various cells in the fibroid. So again, you can see that it's highly cellularized, but also has a pretty significant deposition of extracellular matrix. So that's another key component of uterine fibroid pathogenesis. So what we were interested in is whether or not the stress hormones could also potentially act as a puppet master in the way of regulating genes that are related to the formation, the synthesis, the accumulation of extracellular matrix. And so we're capable of looking at all of the genes that are regulated by stress hormones in fibroid cells, and then classifying all of the genes that may be related to those processes of extracellular matrix formation. And while the various genes are really important, what I want to impress upon everybody is that there's a significant number of genes that are regulated by stress hormone signaling in uterine fibroids, and that this is really specific to the uterine fibroids themselves and does not occur to the same extent in the normal smooth muscle cells. And in fact, when we look at patient tissue, there really seems to be a direct correlation between the expression of the stress hormone receptor, the glucocorticoid receptor, and extracellular matrix, the presence of extracellular matrix. So in patients that have low glucocorticoid receptor or stress hormone receptor expression, those patients also had lower levels of extracellular matrix. In patients that had high levels of positive staining for the glucocorticoid receptor or the stress hormone receptor, they had equally high levels of extracellular matrix. So starting to indicate that there's a mechanism by which stress hormone signaling can be directly related to the stiffness and the bulkiness of uterine fibroids. And so because we're really interested in the mechanism, because the mechanism is going to allow us to start to develop really targeted therapeutics so that we could target these pathways and help figure out how can we develop better therapeutics for uterine fibroid treatment. We started to look at all the genes that are potentially regulated by uterine fibroids. We looked at all the genes that are related to extracellular matrix, and we're using, the cool thing here is that we can use the science of people who have done cancer biology and all other types of tumor biology and figure out all of the genes that could potentially be related to extracellular matrix, uterine fibroid biology, cell proliferation, and then Med12, which I believe somebody's described in this the Foundation Summit this year as key to uterine fibroid pathogenesis. And so what we did was we compared the genes regulated by these various processes that are key to uterine fibroid formation as well as growth, and compare those to the 450 genes that we found to be regulated by uterine fibroids or by the glucocorticoid receptor in uterine fibroids cells. And what we found was when we overlay all of these groups, we found 4 common genes between all of these. And the one that really popped out as really interesting to me was the vitamin D receptor. So others have already demonstrated very nicely that vitamin D is actually very beneficial for uterine fibroids. So vitamin D treatment of uterine fibroid cells can decrease uterine fibroid proliferation. Uterine fibroid tissue treated with vitamin D, you see a decrease in extracellular matrix production. And that, again, vitamin D can also decrease the size of uterine fibroids by increasing cell death. So all those cells that are within that uterine fibroid tissue can be lean towards programmed cell death. And so what we wanted to find out is how would stress signaling impact the vitamin D receptor? We knew that it was a target, but how would that occur? So we treated our uterine fibroid cells with increasing concentrations of the glucocorticoid cortisol. And this middle range is typically what happens, that would be like a normal concentration of cortisol, and that this higher dose in the darker green is going to be your closer to a stress-induced level of cortisol or the glucocorticoid. And what we found is that at this highest level, or this higher level of cortisol, or stress hormone, we see a significant reduction in vitamin D receptor expression. So this shows to me that stress signaling can negatively potentially impact uterine fibroids by reducing this beneficial factor. So vitamin D is beneficial for uterine fibroids, and now we've taken an added stress that's now decreasing the beneficial thing. So basically taking away a good thing. And not only are we decreasing the level of the receptor, so again, remember that this is a lock and key mechanism of hormone signaling, whereas vitamin D binds to its receptor and then elicits some sort of activity in the uterine fibroid cells, and that activity is decreasing proliferation, increasing apoptosis or cell death. Here we can see that in the presence of our stress hormone that we decrease this activity. So this is a readout of vitamin D receptor activity, and we can see that when vitamin D is there, but also stress hormones are there, the activity of this receptor is now down. And interestingly, this is always something that, again, could be very beneficial for designing better therapeutics, is that this effect of stress signaling seems to be really specific to the fibroid cells itself. So when we do the same experiments in normal uterine muscle cells, we don't see a decrease in the vitamin D receptor expression. So it seems to be that stress hormone signaling is doing something really unique to uterine fibroids. And so how could this potentially play a role in, or even compound, racial disparities in uterine fibroids? So Black women experience more severe disease. They experience disease with an earlier onset. So the onset of first fibroid comes much earlier in Black women compared to white women. In addition, Black women are more likely to be vitamin D deficient. So in our model, by which our stress signaling via the glucocorticoid receptor can inhibit the activity of the vitamin D receptor by decreasing its expression. And vitamin D is known to block proliferation, apoptosis, as well as its activity in the fibroid cells. We can see that in a scenario in which Black women are already have less of the hormone, now with the addition of stress, they also have less of the receptor. So the whole lock and key mechanism is lower, potentially lower in Black women. And in fact, when we looked at our tissue samples obtained from either Black or white women, we found that the expression of the vitamin D receptor in that fibroid tissue appears to be much lower in Black women compared to white women. So again, potentially the stress along with vitamin D deficiency could be becoming kind of an additive effect that may lead to greater uterine fibroid size and potentially even earlier onset of disease. Now, to take a little bit more of a positive note, we know that green tea, and specifically green tea extract in uterine fibroid cells, has been demonstrated to reduce uterine fibroid volume and reduce uterine fibroid-related symptom severity. And this may be one mechanism by which we could potentially fight against some of those stress signaling pathways. So in another model, so there was a study looking at children who stuttered. They found that the addition of green tea, so green tea consumption, significantly reduced stress hormone levels in these individuals. And so it could be that green tea could be one way in which the addition of green tea could be one way in which we fight against the response or the effects of stress hormones. And kind of, what's yet to be discovered as to whether or not any of these beneficial effects of green tea related to uterine fibroids are mediated by decreasing stress hormone levels. So this is kind of future studies and research that we can do. So with that, I'd like to just kind of summarize some of the conclusions that we've come with today. Certainly what we've discovered is that stress signaling can increase uterine fibroid proliferation and regulate act as that master kind of regulator of pathways related to the production of extracellular matrix in uterine fibroid cells. And that certainly utilizing a holistic therapeutic approach. I talked about green tea is one way in which we can supplement conventional therapeutic approaches, but certainly other avenues in which we could potentially modulate stress in women may benefit and serve as a more holistic approach to uterine fibroid treatment. As I mentioned, the more we understand about how hormones signal in uterine fibroids, the closer we are to developing those targeted therapeutics that we can use long term. So, the drawback of using therapeutics that targeted the ovarian sex steroids, estrogen, and progesterone was that there was off-target effects that limited their long-term use. However, if those same hormones act very specifically with stress hormones in fibroid cells, potentially something about that interaction that's really unique to fibroid cells may allow us to target that and eliminate all of those off-target effects in our brain and our muscle and our bone. In addition, we could target those unique effects between hormones, but we could also look at how those stress hormones act or how they behave very differently in fibroid cells compared to normal cells. And that can also be potentially therapeutic targets. And then I want to end on the fact that, we understand what we know in science based off the models that we use. So we use a lot of human patient tissue that's donated after surgeries. And so in order to really create research that reflects disease in all races, because clearly there seems to be a disparity or differences in how uterine fibroids develop across races, we really need to build inclusive practices in uterine fibroid research that we include tissue from Black women and from white participants and patients in all of our research, that we can really discover what's happening across the board and create therapeutics that are going to be beneficial for all. With that, I'd like to thank our funding source for this. This is NIH funding, so it's funded by the U.S. government. And without that, we wouldn't have what we know today.
Dr. Whirledge, that was fascinating. As a woman of African descent, a little eye-opening and heartbreaking simultaneously. There's so many instances where the societal factors that impact our health are not discussed. So I applaud you for putting so much effort into bringing this into the public sphere, because it is incredibly important. Can you share a little bit more about the backstory of your research and how you came to specifically study stress and fibroids?
Sure, thank you. And thank you very much for having me for this and for us having this conversation. I think it's so important to be able to talk about the science as well. So my research very generally focuses on, there's a big umbrella of stress and biology of the uterus. And this includes diseases of the uterus, so uterine fibroids, but also fertility. So that's really what brought me to the topic of stress as a research interest. So I joined a lab and they were really interested in how stress may impact fertility. And anecdotally, we all know of people who have had very stressful lives or tried to undergo IVF and been really unsuccessful with that. And then they stopped, adopted a child, and then were suddenly able to conceive again. So this really lack of understanding of how stress impacts our physiology, specifically in our reproductive tract. We all have a concept that it could be bad, but not really understanding how it could be bad. So that was really my interest, is really being one of the groups is really focused on what does stress do to female fertility and female uterine biology.
Absolutely. That's critical. And we do all know stories of people who have struggled to conceive, and then once they're, like you said, either adopted or successfully had an in vitro fertilization, then they just conceive on their own. It's so incredibly interesting. And you mentioned so many things, but the endocrine system specifically, as I've approached menopause, I recognize that we really take for granted the orchestra that is the hormonal dance that just happens every month. And because oftentimes also too, if you're struggling with uterine fibroids, sometimes that monthly dance can cause some agonizing pain in the body. But your work here is so important about the adrenals and ovaries, and it's important to understand that when you're in your reproductive years. So I appreciate you going into depth about the ovaries, brain, and the adrenals. Now, why is the brain a factor for those who may not know?
So the brain is kind of like it's the central organization point. It's kind of like the person directing the TV crew, et cetera. So they're kind of really calling the shots. It's the input of all signals. And I think the endocrine system, to me, is one of the most fascinating things, is because it's not a unidirectional system. So our body senses our environment, then it perceives those signals and responds to those signals. Again, trying to always go back to a even keel, like a homeostatic point. And so it then sends out hormones to various regions of the body to create the signals. And then once we've gone back to normal, the brain receives those signals and says, okay, we're back to where we want to be. Let's shut down that pathway. So the brain is kind of the coordinating center for all of this. And the rest of our body is kind of responding to that and acting most of the time appropriately, but sometimes in disease states inappropriately.
Certainly, absolutely. And I love your analogies like lock and key and Batman and Robin. Those really help you to visualize what you're explaining. Can you delve a little bit more into the lock and key mechanism of estrogen and progesterone?
Yeah, so all of these hormones, so if we want to put on like our school hats and think for a second, so these hormones were actually, at one point they evolved for their very specific purposes, but at one point, very millions of years ago, they were originally a common hormone, and they evolved for their very specific purposes. So they had to have something that allowed for that specificity in the ovary versus the brain versus the adrenal gland. And so that's the thing that really evolved, is its interaction with its receptors. So we really think about, if we want to keep a really simplistic view, there's this blob of a hormone that's circulating in our blood, and only in cells in which it has the receptor, the ability to bind to it. So say estrogen is a circle, it's looking for receptors that have a circle binding spot. Versus, if we want to keep a simplistic view, progesterone is a triangle, so it only binds to things that have that triangle binding spot. So it has that kind of like specificity, so that you don't have your brain responding to hormones that it shouldn't, or certain cell types responding to estrogen when it shouldn't.
That I've never heard that before. And that is so fascinating. And because, like you said, those receptors are all over the body, which is why when we have hormonal fluctuations, we feel it so deeply.
Yes, especially estrogen. Estrogen is expressed, or the receptors expressed throughout the entire, well, not throughout the entire body, but in those key menopausal organs. So our bones and our muscle and our brain, things that regulate our thermos, so why we feel hot flashes, etc.
Absolutely. Yes. And I'm so glad that you shared so many fibroid cell photos. I must tell you, when we have a photo of fibroid cells from Dr. Alhendi, and it is the most viewed photo that we have on Facebook.
Absolutely.
And I understand that because our community wants to see what's causing so much angst in their bodies. So your multiple photos, thank you for including that in your presentation. And I'm sure that that was really helpful to many. I had never seen, that type of study as it relates to fibroid cells. So very informative. So I'll delve now more into the glucocorticoids. Did I say that correctly?
Yeah.
And the stress hormone. This is groundbreaking, to say the absolute least. And when you're looking at disparities and stress and how it plays a part in women's experiences, oftentimes you become accustomed to functioning at that fight or flight mode every day, all day, and it's hard to dial it back. And it does have a physical impact on the body, and you have demonstrated that so incredibly. I'm curious, can you talk a little bit more about how you applied the glucocorticoids to the fibroid cells in the, or just some of what that lab experience was, and maybe some revelations that you had during that process?
Sure. So we typically will use a variety of glucocorticoids because we want to really model what happens in women normally. And we grow our cells in culture, so that means our cells are kind of just growing in a little petri dish, basically. And we add it right to their growth media so that they can experience that hormone basically in the same way that these cells would experience it if they were receiving it from the bloodstream, as we know our hormones travel through the bloodstream. And it's really kind of amazing. So we look at how these hormones impact growth and proliferation. Those are some of our key endpoints that we're really interested in, because those are the factors that are contributing to, all the side effects and the morbidities that women have. So the bigger the fibroid is, the more the fibroids they are, the more pain they're going to be in. So we're really interested in those processes that cause that growth and the growth of the cells as well as in number. So those are kind of the things, the endpoints that we look at. And it's really amazing that, stress, kind of the stress hormone at normal levels doesn't do very much. So as I talked about earlier in my presentation, the stress hormone itself is a good hormone. It helps us sense our environment and respond appropriately. But when we're under that chronic stress that you were talking about and those high levels of stress, that's when we get into like the bad kind of aspects of it. So I always think about it like as a kind of like a scale or a rheostat, where too much or too little puts you in kind of a disease place. And that's where we see those bad effects. The normal range, we don't see as many bad effects, but when you get to those high stress levels, that's when we start to see that alone and in combination with the hormones that we know normally drive fibroid growth, such as estrogen and progesterone.
That's so interesting. Thank you for sharing that. And I often say, as you well know, nothing happens in isolation. So if you are seeing fibroid growth and you're experiencing recurrence, which is something that is incredibly frustrating to our community, I myself had, if you have an abdominal myomectomy and 9 months after being sliced open, basically, you're experiencing fibroid symptoms again, it's incredibly frustrating. And those bulk symptoms that come from the larger fibroids, and sometimes not even that large, sometimes it's the location, the placement. They can press on other nerves. They can cause, as Dr. Catharino said yesterday, bowel issues, bladder issues, and it originates from the growth of that fibroid. Yeah. In terms of how the cells divide when they're exposed to these stress hormones, do you have any more insights, or can you expand a little bit more on that division, or just how rapidly it occurred in the lab?
Yeah. So our research that we have done, those assays or those experiments we do, we're looking at days. So we're looking at an increase in, maybe a 20% increase in the growth or the proliferation. So like the more that you have of cells within 2 to 4 days. So it happens pretty rapidly. And we'll say that we always have to, when we design our experiments, we're looking at what does this hormone do to these cells? So when we maximize signaling, what can happen? Now, what women experience naturally may not be the same high levels of hormones constantly. So I don't want the audience to think, oh goodness, my cells are going to be growing, doubling every week. That's not the case necessarily. What we're doing is what we're trying to do is really figure out why this happens, and then kind of translate that to what women actually experience.
I appreciate that answer. I can understand that as well. I was going to head next into some of the genes that you mentioned, and we actually received a question that's kind of along those lines. So I'll start with the question that we just received. Sure. It says, one of the 4 common genes you identified was IL-1 beta. Any
Mm-hmm.
thoughts on IL-1B regulation in fibroids to perhaps counteract stress hormone signaling?
Yeah, so this is something that we haven't started to look at. So in addition to having kind of like a well-established role in regulating the stress response, glucocorticoids are also potent anti-inflammatory agents. So a majority of us have had, some sort of like cortisone treatment, like on their skin, right? Which is a glucocorticoid. That's an anti-inflammatory. If they take some sort of inhaler for asthma, a lot of times that's a glucocorticoid. That's an anti-inflammatory for our lungs. So they also have potent anti-inflammatory actions as well, which again can be really good when they're in that normal range. So what's happening, potentially is that there may be a way in which the stress hormones at a normal range are maybe even potentially helping by counteracting the inflammatory nature of what the immune system is doing in those fibroids. But maybe potentially at stress levels, we go back to this like good and bad. My other analogy I like to use is kind of a Goldilocks hypothesis, where like when you're in that sweet spot of stress hormone signaling, you get good effects. But if you're too much or too little, you could potentially either be altering the immune system as it pertains to like the IL-1 beta, or in a way that's potentially negative for uterine fibroids. This is purely me just kind of like hypothesizing. We haven't done any of that research, but I think it's a really fascinating area.
I think it's a fascinating area too, because, there's so many disease states that are more prolific in certain ethnicities. And fibroids is one of, you look at hypertension, you look at kidney disease, and I wonder, there's probably some translational research that could occur across those other disease states to help to inform the reasons why they're more they have more of an impact in certain ethnicities. But as you were talking more about, kind of stress and environment, and there's a recent NIH study that's upcoming that's going to look at some of those factors that we haven't really explored before, like environmental impact, societal impact. And I think about how, from the onset of menarche, how that woman's experience can influence the more debilitating symptoms. And I'm curious just how we can start to just share this information more to help us to take a different lens on these really important dynamics. How has your research been received, or have you gotten any feedback that has, given you any thoughts on sharing this more broadly or expanding this? And we definitely intend to expand to share broadly.
No, I mean, I think, I feel like as scientists, as researchers, we're very focused on, we have this kind of like persona of like, we're in our little labs and we're doing our things. And I think this is actually this is the critical part, right? It's our ability to translate and tell the people who are actually impacted by the things that we're studying is the part that sometimes as scientists we're missing. And this is something that we really need to, I think, as a field of people who do research, this is where we need to grow. We're really great at kind of answering questions, but then translating that to communities and telling them, this is what we know right now. This is what we don't know. And in the field of fibroids, particularly as it pertains to race, there's a lot that we don't know. I was just looking at like the papers on uterine fibroids. So if you go to like one of the central houses for all housing all scientific research, and you look up all the papers related to uterine fibroids, there's 27,000 papers that are about uterine fibroids, but only 1% of them are about race, and only 0.1% of those cover racial disparities. So there's clearly a lot that we don't understand, and I think probably that's one of the things that I try to keep in my mind is that not only do we not know, but people need to know that we don't know, so that that type of research can be really supported and prioritized. The Black and African American women are the ones who are most impacted by this disease, and that's really where the focus needs to be for research.
Wow. And 1%. And
less when we think about racial disparities. So yeah. That needs to be, we really need to push that needs to be everybody's, the front of their mind when we do research. And this takes a broadening of our mindset when we design experiments. So we need to make sure that when we're doing our cell culture work with our cells in our little labs, that we need to include cells that come from white women and from Black and African American women and Hispanic women. We need to have representation in our research itself so that it can really be applied across everybody who's impacted by this disease.
Wow. That is profound. And not to toot our own horn, but the disconnect that you explained in terms of the general public not being aware of the research is one of the sweet spots that the Fibroid Foundation enjoys.
Yeah,
absolutely. And it's so critical, and I've seen it happen where a patient experience will be explained in great detail to a clinician and a light bulb will go off, and it's happened to me, when we first started doing research. I walked into a room of 16 physicians and I was very intimidated, and I was like, okay, you got to pull it together, you're here, and I was shocked at what, from just my experience, I was able to contribute to help us to develop some new methodology for that particular study. And I'm so glad that we're having this conversation, because the dynamics that occur in the flow, the information, the uncovering, when clinicians and patients have an opportunity to talk and brainstorm, is, I believe, what's going to be the game changer moving forward for us to take medicine to the next level.
Absolutely. I just want to echo that, because I want the audience, specifically patients, to know how important their stories are. There are things that I don't understand. I'm looking at how these cells respond to what I'm doing to them, but I don't know what patients experience. Those symptoms are reflective of the biology that's happening in their body. And that's the part that's missing when we're just hyper focused on what's happening in our experiments, or as physicians, what we're taught as far as what medicine does. We really have to kind of put it all together to really understand comprehensively how to address this disease holistically.
Totally. We just got a comment that says, I know the stress contributed to fibroid growth for me. I do think it was rapid over some months. Thank you for making me better understand this. Wondering how to define stress now when I think of the practicality of everyday life. And I think that that's something a lot of us are thinking about. It's a daily struggle. But I do recognize that some of us are under much greater stressors on a more consistent basis than others. Dr. Whirledge, would you go over the genes that you specifically kind of identified as factors when you were looking at the potential targeted therapeutics, just for edification for everyone?
Yes. And actually, I don't remember them off the top of my head. I've closed out those.
Well, I have two that I'm curious about.
Tell me what you're curious about.
So for vitamin D, a while back, we all heard, vitamin D. And would you just expand a little bit more on why vitamin D is so important and why it has become a major talking point, I'd say, within the last decade? For, if you go to your primary care physician, they're like, are you taking your vitamin D? Yeah. And so when I hear that, when I see those common threads, I always wonder, okay, how did that come to be, and what is the benefit of that specifically?
Yeah, so the fact that vitamin D as a researcher popped up, that was like such an exciting moment for me, because seeing something that connects the dots and potentially can maybe explain partially or contributes to some extent for racial disparities as well. So vitamin D, as kind of like a general concept, has always kind of had pros and cons when it comes to research. So there has been always evidence that there's beneficial effects, not only in fibroids, but in other fields as well. But sometimes those don't always play out when they do large studies. And that could be potentially due to the composition of the studies. So it may be that certain women benefit more from vitamin D than others. And so that's kind of like maybe a story for another day. But the fact that vitamin D, so vitamin D is again kind of one of those lock and key mechanisms, right? So the vitamin D is the thing that your doctor is telling you to take. That's the soluble factors. It's a hormone that your body makes and travels through the bloodstream, but then binds to the vitamin D receptor to cause the effects. So the uterine fibroids can express vitamin D receptor. And when the vitamin D, so when we have sufficient levels of vitamin D, it can act on the vitamin D receptor and has beneficial effects in uterine fibroids. So that's where that kind of two-hit hypothesis or thought that I have is that Black African American women already are known to have lower levels of vitamin D. And then we add on top of that is that any amount of stress may impact the amount of or levels of the receptors. So you could have less of the key and less of the lock in this kind of analogy, leading to you're kind of losing all the beneficial effects of vitamin D in uterine fibroids. And that's kind of what we see to some extent. We saw that there's lower levels of the vitamin D receptor in Black women compared to the whites for their fibroids themselves. So it could help to, as a holistic approach, supplement with vitamin D, think about ways in which we could potentially reduce stress, which I know is a difficult conversation to have as well.
You may spend a lot of time in the lab, but you are really good at explaining things very comprehensively in a way that's easy to absorb, I think. And I think our patient community will really appreciate the way you've explained some of the dynamics of what's happening to our bodies. Because, when you have a short physician visit, you can't go into that depth most of the time. And some patients wouldn't know to ask, but it's so incredibly informative, what you've explained. So what's your take a little bit more deeply on Med 12?
I think this is all part of so most people have, or a majority of uterine fibroids have that Med 12 mutation, right? And the Med 12 is part of the complex so when we think about like the puppet master, that's part of the complex that's regulating the various genes that are expressed in our cells. So I think it's kind of like you're just layering on complexity. I guess probably it depends on which aspect you have. So as a researcher, like the complexity is where the interest is that's what makes our biology so interesting. But as a patient, that makes it really frustrating, right? Because individuals may respond to therapies or supplementation with vitamin D or green tea, et cetera, depending on what kind of combination of Med 12 mutation, stress levels, vitamin D levels you have. So it kind of layers on, but it also helps us explain why people have very different disease symptoms. So I know I kind of hate talking about like the things that we find make this a much more complicated story, but those complications are potential opportunities for targeted therapeutics in the future. So we have to, the science has to catch up with, or the medicine has to catch up with what we kind of understand.
Totally. And I'm assuming that that's where you'd like to see the next iteration of your research go.
Yes, absolutely.
That exact direction. And we would like to see it go in that direction too.
Yes.
So, I am promising you right now that we will invite you back again to share your time with us, and please keep us posted on your evolving research. I find it so necessary on a personal level as a woman of color, and intriguing and necessary as well as a woman with uterine fibroids and for our community. So Dr. Whirledge, thank you for all that you do, and thank you so much for being here with us today.
Thank you very much. And thank you for, this foundation does such important work. It's such a lifeline, I think, to patients and kind of connecting the research and medical community. So I really appreciate what you do as well. Thank you very much.
Thank you. Take care.
All right. Bye.
women in the U.S. will develop uterine fibroids by the time they're 50. But a recent study showed some troubling trends when it comes to how doctors are treating the problem. Local 10 medical specialist Christy Kruger is in the newsroom and has details in our HealthCast.
Well, here's the question. Are too many women getting hysterectomy?
Reaching out to our U.S. senators. You know, this again, I think is low-hanging fruit in terms of an ask for their support. And I think that we can't be shy in expressing to our leadership in the United States House of Representatives what an imperative this is for us. And so where we can get women across this nation mobilized and emphatic about them sponsoring this legislation, that's the momentum we need to get it signed into law.
We're trying to destigmatize conversations about fibroids. Talk to your friends, talk to your coworkers, your family about fibroids.
Issue that impacts 26 million women a year in America, but rarely talked about. We're talking about uterine fibroids. In the worst cases, treatment includes hysterectomies. ABC 10's Van Tu tells us how the condition impacts women of color at higher rates. Now, doctors are fighting for more minimally invasive procedures to treat them.
What we would like to work on is targeting more anti-progestin pathways and develop drugs that do not have such bad side effects.
But randomized clinical trials have been done for heart disease and for cancer and for all kinds of therapies, and they're just now being applied for uterine fibroids.
Yes. So the national audience needs to know that there are so many options for their fibroids. So there are medications that shrink fibroids. There are procedures that you can do to shrink your fibroids.
The Fibroid Foundation works with donors to advance the foundation's mission. Gifts from individuals, corporations, and community organizations fund our advocacy efforts and patient-focused fibroid research for women around the world. Please consider giving today. Your charitable donation changes women's lives and provides better fibroid treatment options. It also supports exceptional women's health care and discoveries that offer hope, healing, and brighter futures. We will include a link to donate in the chat. You may also visit fibroidfoundation.org and click donate. Thank you so much. Welcome back to our programming. I'd like to introduce you to our next speaker, Dr. Mazhar Adli from Northwestern University. He is an esteemed professor of obstetrics and gynecology at Northwestern with an emphasis on reproductive science. And he's going to be speaking with us today about some of his research that is incredibly interesting. We're going to explore the MED12 gene again and talk about mutations in fibroids and what he has uncovered. Welcome, Dr. Adli. It is such a pleasure to speak with you today.
Thank you so much, Sateria. It's a pleasure to be with you guys today.
So, Dr. Adli, our audience may be surprised to learn that you have an oncology background as well. Can you share more about your background and what brought you to study these particular genetic mutations in uterine fibroids?
Sure. So my background is in genetic engineering. So in undergrad, I studied genetic engineering, and I did my PhD in cancer molecular biology. But for my postdoc, I wanted to study genome. How is our human genome is differentially regulated in normal settings as well as in disease settings. When I set up my lab, of course, the CRISPR genome editing technologies became much more prevalent. So in my own lab, I use these technologies and we further developed them to study cancer and other tumors. When I joined Northwestern about 3 years ago, I joined the Department of OBGYN, and fibroid research is one of the strengths in our department. And I remember mentioning to my colleague that we are a genome engineering lab. We are good at this, and we want to map the genome in fibroids. Can you give us some cell lines? We can study them. And their response was that there is no cell line for fibroid research because when you try to take the fibroid tumor and culture that tumor in the lab, all the mutant cells that normally give rise to tumors, they die out. So there's no really cell line. And I was surprised to hear that, because as a cancer researcher, we have tons of, thousands of cancer cell lines in the field. And that's like a really kind of the main thing that drives the cancer research. So I said, well, we are a genome editing lab, so we are good at genome engineering. So we should engineer this mutation, create a cell line for this fibroid research. That's how it started, really. So, and we wanted to study the MET12 because in 70% of fibroid tumors, we see the same mutation in the same gene. And the fact that this, there's a kind of, to me, there is still not good understanding of this mutation, because generally it's considered that when this mutation happens, this MET12 undergoes a loss of function. But to me, it doesn't really make sense, because the mutation happens exactly the same amino acids. Usually when this happens in cancer, that means that the mutation is providing a new function to a gene. Because there are, genetically speaking, there are many different ways you can lose a function of a gene. You can make a mutation and anywhere in the protein that may lead to what we call gene knockout. The function of protein could be deleted. But the fact that all the fibroid mutations happen on exactly the same residue, that means that must provide something new. Otherwise, there could be many other ways you could lose that function. So that's what we studied. Basically, we created that exact mutation using CRISPR genome engineering. And that provided us a new cell line for the first time to now study the mechanism behind these mutations. And in our first story that we recently published, we found that when we make this mutation, it recapitulates multiple features of the fibroid tumors. For example, they do not proliferate as fast in 2D condition, but in 3D, which is similar to what happens in vivo in tumors, these mutant cells, they proliferate much faster. And in line with the tumor profile, they also change their metabolic needs. And they can form tumors in vivo as well. When we inject them into mice, these mutant ones, they can form a tumor, but the wild type cells, that they do not form a tumor. So now we have a good model that we can track. We can take these cells, we can do many other things, experiments about them. So that was the first research that we published about these mutant cells and MET12 mutation.
That is really interesting. Dr. Adli, is the lack of cell lines in uterine fibroids as it compares to the cell lines in oncology due to the lack of fibroid research funding, do you think?
Yes, absolutely. I think funding is one big issue. The second thing is I think technologically we were not as advanced. For example, we could do this one because we are good at CRISPR technology, but even, none of the lab could have done this one, let's say 5-7 years ago, because CRISPR technology wasn't there yet. But the fact that even after the CRISPR technology has been so much widely used, in the last 7-10 years, no one has done it. I think it's a lack of funding for this area. That's definitely one of the main things compared to a normal cancer research.
Yeah, I thought so. And it's so disheartening because of the numbers of fibroid patients. We know of 26 million in the United States. We don't have numbers globally, which is millions more. And with that comment, for me, I just felt the need to highlight the disparity in the size of the community and the need of the community for more research and the lack of funding to be able to provide the basic parameters and information that you as excellent researchers need to start your work. And it continues to frustrate me. It's something that I'm laser focused, and many other advocacy organizations are on changing that dynamic. But thank you for clarifying that. I'd like to back up just a little bit, because I'm sure that our clinicians listening know what CRISPR is, but many of our patients may not. Can you explain what CRISPR is?
So yes, before I explain that, I really want to reemphasize what you just said about this gap between the funding for fibroid versus other things, other cancers, is because, I think there's a gender thing as well. A lot of males are not affected by this one, and we are not really appreciating how big of the problem fibroid tumors are, I think. Almost 70% of the women being affected with this tumor in their life, and around 30% of them have to undergo some sort of a surgery. Is a huge number, like 30%, over half of the population, basically. But males are not being affected. I think that's kind of affects the funding decision somewhere higher position. So I absolutely appreciate what you are doing. I think that's really what we need to change the discourse on this one. So now going back to CRISPR. So CRISPR is what we call this genome editing technology. So it is really changing the course of biomedical research in a way. It allows us to change the genetic information in living cells. So for a very long time, the genetic information was what we call a read-only file. So we could isolate the genetic information, we could read them, and we got better and better and reading this at a higher rates with this next generation sequencing technologies. So for example, we could see what is the mutation, where the mutation is, etc. But we couldn't change anything. We couldn't edit this genetic information. And what CRISPR allowed us to do, it is the first was discovered, was utilized as a genome editing technology in late 2012. So now it allows us to actually go somewhere, anywhere in the genome that we want to go specifically, go there and change the genetic information the way we want. So this allows us to do many things, of course. We can model diseases, we can create a mutation to model this one. We can correct a genetic mutation for many different genetic diseases. There are almost 6,000 genetic diseases, monogenic diseases that are caused by a single gene. CRISPR can potentially be a cure for these diseases. And also there's a wide array of applications in biotechnology, in agriculture. So, for the first time in a way in our human history, we are able to change genetic information in living things. And this allows us to speed up the evolutionary process in a way. So you can also add new things to new traits in a way to a species or to an organism or a cell line. Of course, with this powerful technology, there comes a lot of ethical considerations as well. But in essence, it's a gene editing technology that allows us to change genetic information in living cells.
Thank you for explaining that. And yes, you took the words right out of my mouth. It requires a lot of efficacy and ethical administration of that technology. I'm curious, as I read your paper, collagen is a huge factor in or the heightened levels of collagen in terms of fibroid growth. Can you talk about the relationship between collagen, which isn't often discussed, not on the patient level, and the growth of fibroids and what you uncovered in your research?
Yes. So when we look at these tumors, one of the, as we're starting to talk to pathologists and the doctors, they were saying that when you look at the tumor, it's big tumor, but when you look at the number of cells in this tumor, it's not that it's covered by a lot of cells. So there's a lot of extracellular matrix accumulation in this tumor. And the cells are not super highly proliferative like what we see in cancers. But the tumors get bigger, and almost half of the tumors is this extracellular matrix, this collagen production. So the mutant cells, in a way, release this factor to the extracellular matrix, and the surrounding cells also become as proliferative almost. So we have this, release of these factors from the mutant cells, but they also make the non-mutant cells proliferate as well. The fibroblast becomes also more proliferative. I think it's very hard to model this one, or this entity model, because you need these two factors. And that's why this model that we created now allows us to study this as well, because we found that if we just take a media from these mutant cells and put that media on top of a normal cell, the normal cell also start to proliferate much faster as well. So there is something that this, some factors are being released from these cells. And we saw that when we grow these cells in 3D conditions, they perfectly recapitulate the normal tumor by expressing a lot of collagen genes.
So where would you like to see your research go next, the next evolution of it?
Yeah, well, we are actually right now actively doing very cool experiment, or it's just not a single experiment, but one thing, of course, as a genome engineering person, I want to know what should we target in these cells so that we can prevent this collagen production or this proliferation. But we want to do an experiment we call discovering synthetic lethal interactions. So this synthetic lethality basically means that we want to discover something that would only kill these tumor cells, these mutant cells, not the wild type, cells in the body, because every cell, other cells in body are wild type. Now, how do we do this one? So we have this, using the same CRISPR technology. Normally, in the CRISPR technology, we use this thing we call guide RNA, a short, synthetic RNA. But normally, we just delete one gene at a time, or we do one genetic editing at a time. But there is also a way to do this one in a multiplex way, in a setting where we can actually delete thousands and thousands of genes all at the same time and study how they affect a certain phenotype. So we want to do this one in these two settings because we have created these mutant cells, and we also have a wild type cell, and we want to delete, 10,000 genes, 20,000, all genome basically, 20,000 genes in the mutant and in the wild type cells. And we want to discover the genes that will selectively target the mutant cells. And that way, we were hoping to find that if I find a gene that selectively kills the mutant cells, it means that if we have a small molecule inhibitor to that gene, we can selectively target these mutant cells. And that's what our next big goal is, honestly, to actively go after this one. Of course, we are going to use this model system to understand the mechanism of this fibroids and the mechanism of this MET12 mutation. But what excites me the most is figuring out how we can prevent this and how we can discover some new molecule, new gene, new inhibitory pathways to prevent this proliferation.
That's very interesting. So what's the relationship between the chromosomal abnormalities and the collagen? Are the chromosomes dependent on the collagen? I'm just trying to understand the side-by-side association within the mass of the fibroid, those two things.
So the chromosomes, of course, are in the nucleus of cell. And then outside the nucleus, we have the cytoplasm, and then the cells release this collagen to the extracellular matrix. So it's kind of a microenvironment around these cells is where the collagens becomes really, really critical. These collagens, of course, provide as some sort of a media or environment for other cells to be able to proliferate much faster, much better, basically. So some of the chromosomal abnormalities may lead to this collagen production. So in a way, you are now in an environment that you can survive better, basically. That's what collagen production will provide. And the tumor becomes, the mass becomes bigger and bigger with the collagen production. But the basis of all this is probably the genetic abnormalities, because MED12 itself is involved, is a critical factor. It's involved in many different processes, including the DNA replication and transcription. When this is messed up, it also leads to chromosomal abnormalities as well. So although the genetic basis of fibroids is simpler compared to a cancer, meaning that we don't have massive, chromosomal abnormalities like we see in normal cancer tumors. But still, compared to normal tissue, there's a lot of chromosomal abnormalities in fibroid tumors as well. And those could be driven by some of the driver mutations in MED12 and other mutations.
Yeah, I understand, and I appreciate that explanation. Thank you very much. I'm also thinking that sometimes for those who are not as intimately involved in fibroid research as you may be, the comparison to cancer and that it's not maybe as prolific in terms of coverage within the body is one factor, but if you lose half your blood supply or more, that can lead to even more, detrimental endpoints as severe as some cancers. And I just want to highlight that many women and menstruators are walking around every day going to work with hemoglobins that are just shockingly low, that are causing them to take shallow breaths, that their heart is working overtime, that it could lead to, an incident where there's a loss of life. And it's just very interesting to me to understand the dynamics that you've uncovered. Dr. Adli, is there additional information that you'd like to share with us today? Because I want to make sure that you're able to touch on all of the major points of your research that you want to.
Yeah, no, it's really what you said is resonates a lot with me, because sometimes I feel guilty as a scientist, because I didn't start working on fibroids a long time ago, just recently started, and I wasn't aware of the severity of the problem before, honestly. And now as I read more and more about this, and now as I'm involved more in this one, I was like, this is really a serious problem. How come no one had brought this to our attention, or how come we didn't knew about the severity of this problem before? The other thing I think we are trying to investigate is fibroid tumors. The genetic ancestry is being differentially affected by fibroids as well. Black women are affected more and more severely by it. So we also look at the genetic basis of this disease is more thoroughly between different populations. Asian population, European population, African American population, and there are some genetic predispositions that are specific to each of these populations, and we think they are also playing a key role, kind of making some of these populations more prone to getting this disease, or being more severely affected by the disease. Some of this genetic I shouldn't say abnormality, but just genetic differences between the populations, they are very subtle. So there is a kind of a research approach called genome-wide association study. But basically, you look at these differences, small differences between two populations, and you say, what is associated more with the disease? And so these studies have been done, thousands of such studies have been done. But the problem is, in our genome, we have 3 billion letters of this information. And between any two individuals, if you look at the person right next to you, there will be about 1 million difference between you and that person. And some of these differences may be associated with the disease. But which genes are the targets of these small single nucleotide changes? It's very challenging to find that one. But with the technology that we use, we are actually able to fine map these associations. We say, okay, this is the difference, this A to G change is associating with the disease. Now, which gene is being affected by this small difference? It's a tiny one letter change. If you think about it, there's a huge encyclopedia, and there's just one letter change in this encyclopedia, which may predispose a patient. And we are now trying to understand what this letter change, what happens to the rest of the genome. And if it changes exactly one letter, how can we, which phenotypes are we able to change? And which genes are being changed by this one? So that's another kind of a research project about the fibroid that we are undertaking, basically using our expertise in genome manipulations and mapping, and combining with this already published results, and figuring out this kind of minor differences. So that's another area of research in the lab.
Yeah, that's really interesting. I had two thoughts as you were speaking. One is all ethnicities are part of our community. Like every single ethnicity pretty much is represented in our membership. And I wonder if there would be any usefulness in studying women and menstruators who don't have fibroid symptoms and comparatively at some point. I'm just tossing out an idea that I have from time to time, but I wonder if it's multifactorial in terms of the impact on the African American community or women of African descent, because we know that there are some genetic differences, as you alluded to, that aren't that drastic, but then we are possibly looking at environmental factors as well. So I think it's probably multifactorial. Do you agree with that?
Absolutely. Absolutely. I think those genetic differences, are there, but they become kind of phenotypic, or they lead to certain phenotypes with the environment. So absolutely. So, this, if that person was in a different environment, probably that genetic difference would not have been, as predominant. I think there are definitely several factors involved in this kind of predispositions. And your suggestion, including normal kind of person that didn't have any fibroids in the studies, I think is very critical, as that they provide the basis of these things, basically, as for us, kind of a normal reference point. For some of this, so you are also alluding to one of the challenges generally in research, that we have some research models, but it's very difficult to capture all the genetic diversity, because we don't have that many cell lines, for example. It's right now we created one cell line that is from, one genetic diversity, basically one ancestry, but really it would be amazing to have, 10, 20 different cell lines, and be able to do some of these experiments in this diverse population, with some of them being completely normal as well. In certain experimental settings, it's easier to include such diversity, because this genome-wide association studies, we really need to look at the genetics of thousands of normals and thousands of kind of people who got the fibroids. But in experimental setting in the lab, it's very challenging to capture that diversity in the lab.
Yeah, I appreciate that as well. And I know that Dr. Cynthia Morton did a study a while ago, and when we talked, I think it's probably been a decade now, but she needed 250 women of European descent in the United States and 250 women of African descent, and it was a challenge to find them. But my hope is, through programs such as this one, and you being so forthcoming and explaining your research, that our community will better understand their critical role in research moving forward, and to rely on our organization to vet studies that are going to be patient sensitive and have as little impact to the patient's daily lives as possible. So those are all factors that are very important moving forward, I believe, for us to really understand uterine fibroids and make women's experience better. You know, it's just the suffering and these stigmas can't continue. So Dr. Adli, it's been such a pleasure to speak with you. I've learned so much, and we look forward to tracking your research and having you back to join us. And thank you so much. I know you're at another conference, and thank you so much for taking time today to speak with our community and share your important research.
Thank you so much, Adli. It has been a pleasure really to be with you guys, and thanks for this opportunity. Look forward to stay in touch and hopefully join you guys for another event.
Absolutely. You take care. Thank you for joining us for Fibroid Summit 2023. We welcome you to join us in our efforts to support fibroid research. Visit our website, fibroidfoundation.org, and click on the Research tab. If you are facing a menstrual health challenge, you don't have to make that journey alone. We encourage you to reach out to us to join a chapter, start a chapter, or just for general information. We appreciate your presence and input during our 10th anniversary month. We strive to continue to share informative and enlightening research with you. Together, we're making a difference in women's health. Thank you and be well.